Hello again, everyone. I'm going to go ahead and continue our lesson. This is part number 2. So you can see here, we have our learning target 9A. I can write arithmetic sequences with an explicit formula or rule and use them to model situations. So we're going to be talking about arithmetic sequences. Arithmetic sequences, well, what is that? That's the difference of consecutive terms and it's constant. So difference of consecutive terms is constant. So when we're talking about this, we're referring also in connecting it to the common difference. The common difference is referred to the constant difference as well. So the constant difference and common difference are pretty much the same thing, and it's denoted by the variable d. And we'll talk about that as we talk about introduce the formula or the rule, the equation for it. Here's an example of an arithmetic sequence. We have a 2, 4, 6, 8, and a 10, right? So I already told you that it's an arithmetic sequence, but we're going to prove it. So an arithmetic sequence with the common difference of 2. Why is it a 2? Well, here it is. In order for you to prove it's an arithmetic sequence, you have to find the differences of the consecutive terms. So what am I talking about? Here's your first one, A1, A2. So basically you're subtracting, that means the difference, these two, so it's 4 minus 2, which will give us 2. You keep doing that, so you always subtract the consecutive terms. So that now it's 6 minus 4. 6 minus 4 is 2. Then as you continue with the sequence, 8 minus 6 is 2. Then you have 10 minus 8 is 2. If all of these differences are the same, in this case they are 2, then there is a common difference. So that means this sequence is an arithmetic sequence. So a sequence is arithmetic if there is a common difference. A sequence is not arithmetic if there is not a common difference. So if you were to get like 2 and then 3, you could automatically stop there and then say it's not arithmetic because you already ended up something with that's not the same. Okay, so please make sure you do test all of them just to be sure. Here's another example on the bottom here. 3, 5, 9, 15, and 23. Dot, dot, dot. So first step, find the differences of the consecutive terms. So we have 5 minus 3, which is 2. Then we have 9 minus 5 for these two consecutive terms, which gives us 4. I could stop right there and say it's not the same because they have different, there's no common difference, because you have a 2 here and a 4 here. They're not the same. So notice I showed the work for the other ones. 15 minus 9 is 6. And last but not least, 23 minus 15 is 8. So since they're not the same number here, when we calculated the differences of the consecutive terms, this implies that the sequence is not arithmetic. Okay? All right, we're going to do one more. So notice here, we have an example of negative 4, 1, 6, 11, and 16. So this one has a negative, so be very careful with the negatives here. So we're going to have 1 minus, and then you put the quantity, parentheses, of negative 4, so that way we go ahead and add them. So it becomes an addition problem. So 1 plus 4 is 5. Then you go 6 minus 1 is 5. 11 minus 6 is 5. Then you have 16 minus 11 is 5. So notice that all the differences of the consecutive terms are the same. So this implies that the sequence is arithmetic. So there's my little written portion to answer the questions. Last one, you guys can try it. Pause the video if you like. 17 minus 14 is 14 minus 17 is negative 3. 11 minus 14 is negative 3 as well. So far so good. It's arithmetic. Keep going. 8 minus 11 is negative 3. And then 5 minus 8 is negative 3. So from this point, you notice that they all have the same common difference of negative 3. So the sequence is arithmetic. Thank you.